The ocean is simply wondrous to behold. It is estimated that there is 1.35 billion trillion litres of water in the ocean. All that water come from somewhere, right? It is said that the oceans accumulated purely through rainfall and perhaps comets. This process took billions of years. When looked at through the lens of time, the oceans are nothing more than giant puddles that have formed at the lowest points of the earth. The water in these giant puddles contain useful elements that have been washed off the land. One such mineral is sodium, and the other is chlorine. Some of the chlorine is said to have come from the rocks on the land. However, the majority of the chlorine is said to have come from hydrothermal vents called black smokers. The chlorine released is an acid, while the sodium in the ocean's water is a base. When black smoker chlorine makes contact with sodium, something very interesting occurs. A reaction takes place. This reaction is called an acid-base reaction. This acid-base reaction creates salt, the very same you use on your kitchen table. To put things simply, salt is nothing more than bonded sodium and chlorine. And seawater is nothing more than an aqueous solution of salt. To extract the chlorine, you will first need to collect a bucket of seawater. The aqueous solution you now have in your bucket will have the sodium chloride, salt, combined with the water. Now all you need to do is separate the sodium from the chlorine. This can be achieved by using an electrolytic cell. Now simply add the seawater to the electrolytic cell and seal using the lids provided. This is a very basic electrolytic cell. This cell was made by using components I found laying around the house. It consists of two main components. The two cells are identical. Each cell has a carbon electrode. And both of the cells are joined by a piece of hose. Once connected, each cell will have its own designation. One will be the anode and one will be the cathode. Cotton wool is inserted into the hose to act as a membrane between the two cells. This keeps the solution in the anode and cathode cells separate while the electrolysis process occurs. Alligator clamps are connected to each of the electrodes. The carbon electrodes submerged in the fluid are highly conductive. This allows for the passage of electricity to occur. These clamps are connected back to a car battery. The red cable should be connected back to the positive terminal on the battery. This is the anode. The black cable should be connected back to the negative terminal on the battery. This is the cathode. Okay, so as you can see here, everything is good to go. We have a solar panel, back to the charge controller along the cable, back to the battery. From the battery we're going back to a set of alligator clamps connected to a cable, back to the actual electrolytic cell itself. So positive to positive, negative to negative. Now I haven't plugged that in yet, so obviously that's the next thing to do. I've just got to connect that connection to that there, and then it will be good to go. In fact, we can probably just make a small connection there now, just to see if it's going to work. So what we want to watch is these electrodes here. They should bubble, in all seriousness, hopefully. And there we go, so you can actually see that bubbling in there. Maybe a bit hard to see, but it is doing exactly what it should be doing. And you've got to keep checking these cables, make sure they're not going to get hot. And that one there, that's starting to bubble as well. And that's what we're chasing. There are several ways that you can improve this. One of the ways, and the most effective way to improve it, which would also result in a larger power draw, is to increase the number of carbon rods in the system. So instead of just having the one carbon rod on each side, you'd have a ring of them, and you'd have them longer so they went down further into the actual water. So at the moment they're only going about halfway down there, and we could certainly improve this by going full distance, so we could go almost to the floor of the actual container itself. It's good to see that it's actually working though. That's exactly what we were chasing. It'd be interesting to get a voltmeter now and actually just check the voltage of the battery, see how many amps it's actually, or how many volts it's stabilizing at. I know yesterday I was at 13.44 while I was charging. I'm assuming it would be the same now, but with a bit of a draw on it, I'd expect it to drop back possibly to 13 or something like that, with a bit of a load on it. This stage here, not much is happening with this, although they are actually beginning to fill already. It'd be interesting to see which one fills up more. Remember, the negative side over here is actually producing sodium hydroxide and also producing the hydrogen gas from the top here, whereas this side here is producing the oxygen and the chlorine. I thought I'd just give you a close-up of one of the electrodes doing its job. You can see all the bubbles coming off it there. So the way it works is, obviously the negative current comes in at that point. It actually associates with the water, passes through the bridge, and then reconnects on the positive side with the positive electrode, which completes the circuit. So it's just a circuit of electricity going through there. And it is this electricity that actually strips apart the molecules in the seawater. So for example, it will create ions, and ions will pass through that bridge, it's a salt bridge, through to the positive side terminal, where the chlorine will gather. So the chlorine ions will pass from the sodium hydroxide side through to the actual positive side of the device. As you can see in this photo here, it's actually tainted green, and that's evidence that chlorine is indeed forming. So I hope I haven't confused you too much. Basically, it's very simple. An electrolytic cell pulls apart the salt in the water to create both sodium hydroxide on one side of the electrolytic cell, on the cathode side, and on the other side, the anode side, you'll be able to create chlorine. Now you can connect it just straight back to a car battery. It's not necessary to connect it back to a solar panel. However, I connected it back to a solar panel purely because I wanted to get that extra power into the device while I was operating it without sending the car battery flat. I find it amazing that it is so easy to make chlorine from something as abundant as seawater. Basically put, you can take a bucket of seawater and create a commodity of value that is highly prized in modern civilization. Chlorine has so many uses. It can be used as a cleaning product, but it can also be used to treat drinking water, as it is the world over. Thanks for watching my video on how to make chlorine. If you have any questions, please do not hesitate to ask in the comment section below. If you have found value in the presentation, please give the video a thumbs up and please subscribe. And if you're feeling extra adventurous, please visit michaelfarmer.com to see what is happening over there as well. That's MICHAELFARMER.com. EALFARMER.com. Until next time, thanks again and cheers.